Good morning, everyone. Myself, Dr. Kritika, Assistant Professor working in SRM Institute of Science and Technology. Take a moment and picture the skyline of any major city you have visited. New York, Dubai, Shanghai, Mumbai. What do you see? Towers of steel and glass stretching upward. Monuments to human ambition. But here's a question we rarely ask. What if these giants could breathe? Today we are going to explore a radical reimagining of urban skyline. One where architecture doesn't occupy space but actively collaborates with nature. We are talking about bioclimatic skyscrapers, building designed not as barriers against environment but as living, breathing ecosystem integrated to it, integrating nature for sustainable urban living. This isn't science fiction. These buildings exist. They are being built right now, and they might just hold the key to how we survive and thrive in the cities of tomorrow. So let's begin from the problem that makes this urgent to the principle that makes it possible to the future. It's already creating. Let's start with some hard truths because understanding the urgency is what makes everything else matter. Look at these three numbers. 58%. More than half of world population now lives in cities. By 2050, the number climbs to 68%. That's nearly 7 billion people calling urban areas home. Our cities aren't just growing, they are but exploding. And secondly, 40%. Building alone consume 40% of global energy and they produce 30% of greenhouse gas emissions. Let that sink in. The places where we live, work, and sleep are among the largest contributors to climate change. Thirdly, 3 degrees Celsius. Because of concrete, asphalt, and the absence of vegetation, cities can be up to 3 degrees Celsius hotter than surrounding rural areas. This is the urban heat island effect. And in the warm world, those 3 degrees can be the difference between uncomfortable and deadly. Traditional skyscrapers, the glass and steel towers we celebrate as symbols of progress are essentially energy intensive monuments to consumption. They demand constant air conditioning, artificial lighting, and massive infrastructure just to function. But what if there was another way? What if buildings could work in nature instead of against it? That's what climatic design offers. It's not just an architecture choice, but it's a survival strategy. What exactly is a bioclimatic skyscraper? Let's define. What exactly is a bioclimatic skyscraper? At its core, it's a high-rise building designed to respond dynamically to its local climate, using natural forces like sun, wind, water, and vegetation to regulate temperature, light, and air quality. Think of it as architecture with a built-in immune system. Let me break this down into three defining characteristics. Firstly, climate responsive. These buildings adapt to local weather patterns and seasonal changes. They are not one size fits all design cloned from a blueprint, but a bioclimatic tower in Singapore looks very different from one in Copenhagen because the climates are different. Secondly, self sustaining. They generate renewable energy on site and manage their own water cycle. They are not just consumers, they are producers. Thirdly, ecologically integrated. Through green walls, green roofs, and designed habitats, these buildings support biodiversity. Built nest in them. Insects pollinate within them. They don't just occupy an ecosystem, but they become one. This is architecture that asks, what does this place need? And then answers with design. Now, How do we actually build something like this? This shows four key principles. Number one, passive design. This is about working smarter, not harder, by orienting buildings to maximize natural ventilation, daylight, and thermal mass. We can reduce mechanical cooling and heating loads up to 50%, half the energy, just from thoughtful orientation and materials. No fancy technology required, just smart design. And second principle, renewable energy integration. Solar panels, wind turbines, geothermal systems. But here's the key. They are integrated directly into the building structure, not bolted as an afterthought, but designed in from day one. The building is a power plant. And thirdly, green space, vertical garden, sky terrace, and green roof. These are these aren't just pretend, they cool buildings naturally, filter air, reduce stormwater runoff, and restore urban biodiversity. In a dense city, a green wall is a vertical path. A sky terrace is a communal garden 40 stories up. And lastly, water management. Rainwater harvesting, grey water recycling, natural filtration system, and the goal is to close the water loop within the building itself, capture what falls, reuse what flows, and minimize what leaves. These four principles aren't separate features, they work as an integrated system. Green spaces cool the building, reducing energy demand. The reduced energy demand makes renewable energy more viable. The renewable energy powers the water management system. It is a virtual cycle. Let's look into the Central Park, Sydney. Let's move from principles to practice. Let me tell you about one of the most celebrated bioclimatic towers in the world. One Central Park in Sydney, designed by Jane Novel and completed in 2013. Imagine two residential towers, but instead of bare glass facades, they are draped with over 38,000 plants across 250 species. It's a vertical forest in the heart of city. Three innovations make this building extraordinary. Firstly, the heliostat mirror system, a motorized cantilever reflector, essentially a giant mirror, redirects sunlight into shaded areas of the building and to the path down. So even spaces that would normally be dark receive natural light. Its architecture is share sunlight. And secondly, vertical hydroponic gardens, designed by Patrick Blanc, a pioneer in living walls. These gardens regulate building temperature and improve air quality naturally. No mechanical filters, just plants doing what they have done for millions of years. And thirdly, a tri-generation plant, an on-site energy plant that reduces carbon emission by 25% compared to conventional building. One Central Park doesn't just consume less, it produces smart. This isn't a prototype in a lab. People live here. They wake up surrounded by greenery 30 stories above the ground. One Central Park proves that bioclimatic design can be beautiful, functional, and livable. This is about gold engineering. The Bahrain World Trade Center. Let's travel from Sydney to the Persian Gulf to the Bahrain World Center, which is completed in 2008. This building asks a different question. What if architecture itself could generate power? This is the world's first skyscraper to generate large-scale wind turbines into its structural design. Three massive turbines, each 29 meters in diameter, are suspended between two sail-shaped towers. Here's the brilliant part. The towers aren't just support for the turbines. Their shape is the technology. The aerodynamic sail-like forms, funnel, and accelerate prevailing gulf winds directly towards the turbine, and the buildings becomes a wind machine. A result, these turbines generate around 11 to 15 percentage of building's electricity from wind that was already there just waiting to be harnessed. This is what I mean, what I say architecture as an energy machine. The Bahrain World Trade Center doesn't fight its environment, it reads, shapes itself, and turns natural forces into power. We have talked about energy and emission, but climatic design delivers benefits that go far beyond sustainability metrics. Let's look at these three dimensions: health and well being. We have talked about energy and emissions, but bioclimatic design delivers benefits that go far beyond sustainability metrics. Let's look at three dimensions of its impact: health and well being. The access to greenery and natural light isn't just pleasant, it's medically significant. Studies show it reduces stress, improves cognitive function, and lowers rate of respiratory illness. Biophilic design that connects people with nature, is now recognized as a genuine public health intervention. What a building has green walls and natural ventilation, it's not just green, it's healthy. Economic value. Here's a number that gets every developer's attention. Green certified buildings command 7 to 10% higher rental premiums. They see 20% lower operating cost. Property values rise in proximity to bioclimatic developments. Sustainability isn't a cost center, it's a value driver. And lastly, social impact. Shared green terraces and sky gardens create something rare in dense vertical environments. Community space, they reduce urban isolation. They create inclusive public spaces where neighbors actually meet. In a world where loneliness is being called an epidemic, bioclimatic design builds connection into the architecture itself. Now, I want to be honest with you. This isn't easy. Bioclimatic skyscrapers faced real challenges: higher upfront cost, complex maintenance, regulatory hurdles. But here's what inspires me: every challenge is driving a wave of innovation. Smart building systems, AI driven automation now optimizes energy use in real time, cutting operational costs dramatically. A building learns, it adapts, it gets smarter over time. Modular green walls, prefabricated living wall panels, or reducing installation complexity and maintenance requirements. What used to be bespoke and expensive is becoming scalable and repeatable. And policy evolution. Cities like Singapore and Copenhagen aren't just encouraging green building, they are mandating it. Green standards are becoming building codes. Water aspirational is becoming expected. The obstacles aren't disappearing. We are getting better at climbing over them. And what is the future of urban architecture? Let's look ahead. The timeline on this slide shows where we are going. 2025 to 2030. Net zero building mandates expanding globally. Carbon positive skyscrapers, the building that remove more carbon than they emit, are becoming the new benchmark, not the exception. And the next 10 years, 2030 to 2040, the urban vertical forest becomes standard. Buildings that generate more energy than they consume won't be headlines, but they will be normal. And 2040 to 2050, bioclimatic districts replace isolated green buildings. We are no longer talking about one sustainable tower, we are functioning as integrated ecosystem. And beyond that, living architecture, buildings that grow, self-repair and adapt. Biology and engineering fully merged. This might sound like science fiction, but researchers are already experimenting with self-healing concrete and bioresponsive materials. The bioclimatic skyscraper is not a trend, it is the inevitable evolution of how we build cities. And what is your key takeaway and your role in it? Before we close, you should carry these 3 points with you. First, nature is infrastructure. Green systems are not decorative afterthought, they are essential building components, as critical as steel and concrete. When we design with nature, we design for resilience. And secondly, energy is local. Buildings should generate their own power from sun, wind, and heat. The era of centralized fossil fuel dependent energy grids is ending. The future is distributed, renewable, and on site. Thirdly, cities can heal. Bioclimatic design doesn't just slow urban environmental damage, it reverses it. At scale, these buildings can cool cities, clean air, restore biodiversity, and reconnect people with nature. And now, 3 questions I am leaving with you. 1. How can existing buildings be retrofitted with bioclimatic features? Because we can't just build new, we have to transform what we already have. And second question, what policies in your city support or hinder green architecture? Change happens at the intersection of design and policy. And last, how do we make bioclimatic design accessible, not just aspirational? Sustainability can't be a luxury for the wealthy. It has to be standard for everyone. I will leave you with one final question and it's personal. What will you contribute to sustainable urban living look like? Whether you are an architect or engineer or a policy maker or an investor or even a citizen, bioclimatic design needs all of us. The buildings of a future aren't just going to appear. They will be built by people who looked at the problem and choose to reimagine the solution. Thank you.